All right, so now we're going to look at word problems. Word problems are one of those things that can be annoying because let's look at this problem here. A large piece of silver jewelry has a mass of 132.6 grams. A graduated cylinder initially contains 48.6 ml of water at 25 degrees C. When the jewelry is submerged in the graduated cylinder, the total volume increases to 61.2 ml. Determine the density of this piece of jewelry. That's a lot of words, right? And you may be thinking, I know how to do density. If you give me mass, give me volume, I'll find density. But this, you have to do some work. So why do we even have to deal with word problems? Well, we have to deal with word problems, and it's important to work with them because these types of problems are more realistic to the problems you find in an experiment or in the real world. For instance, in an experiment, you're not gonna necessarily know the volume right away. You may have to do some calculations. And then also, this shows that you fully understand the concept of, in this case, density, right? Having to do some calculations before shows that you actually know density. So let's go ahead and let's do some problems. Now, how you solve word problems and the procedure, it can vary. And some people learn a different way. I'm going to go through some tricks and some guidelines for how to do it. But if you have a different way, if you want to tweak this, that's great because there's no hard and fast rule. So the first thing we have to do is we need to realize what our goal is. Okay? What is it that the question is trying to find? Then we figure out what's given to us. The third thing is it's nice to draw a diagram where you start, what happened in the word problem, and how we got to that final problem. Then triage. So if you've ever gone to the ER, you may have, the first nurse is what's called the triage nurse. The triage nurse basically takes the information in and says, all right, is this an emergency or can you wait a little bit? Is this a heart issue or is it a bone break? Because that determines what has to be done. In the same way, we're going to do the same thing with our problems. We're going to figure out what kind of problem it is, because once we know what kind of problem it is, we can then say, okay, what kind of equations or conversions or constants are we going to use? Then we solve for it. And then finally we check. And checking it is just saying, going back to step number one, what's our goal? Our check is to say, did we actually answer that goal? All right, so let's start with a word problem. And let's start with one outside of chemistry. So let's say we have this. John's mom gave him $20 and asked him to buy 3 pounds of apples and 10 donuts. The price of the apples is $2.50 per pound, and each donut costs 80 cents. How much money does John have remaining after he finishes his shopping? All right, so first, our goal. Our goal is to figure out how much money John has remaining. Okay, so not how much he spent, so how much money he has remaining. And let's see what we're given. We're given that at the start, he had $20. His name, the fact that his mom gave it to it, none of that matters. And he bought 3 pounds of apples and 10 donuts. We have some prices for them. We have $2.50 per pound for the apples, and the donuts cost 80 cents. And so we want to go from what we started with. We spent this much, and then we want to figure out how much is remaining. So this is our diagram. It's not much. Sometimes you have more of a diagram of what's happening. But in this case, we want to know what is being spent, and then we can find remaining. All right, so let's triage the problem. Now, in triage, typically in a chemistry problem, and we'll do some, you're kind of deciding, okay, whether this is a reaction problem or a density problem. Here, it's a money problem, right? We know how money works. So there's not much to triage here. We know, hey, if you start off with 20 and you spend 12 bucks, you have $8 left. But let's think of appropriate equations. Well, appropriate equations is the amount he has remaining, I'm going to call that R, is equal to what he started with minus what he spent. We know that that was $20 minus however much he spent. All right, now let's see what else we have. Well, we have another conversion, and I actually already did it. Here, it actually said it's 80 cents. Well, I knew, based on the fact that I've been spending money for quite a while, that 80 cents equals $1. So I was able to do this conversion in my head, but there it is, all laid out. All right, so now let's do this problem. We need to find out how much was spent. All right, so we have 3 pounds times $2.50 per pound. Notice when I do that, the pounds will cancel out. Plus 10 donuts, sounds good, times 80 cents, or 0.8, and that's per donut, so the donuts cancel out. All right, so that's 3 times 250, so that's $7.50, plus 10 times 80, so that's $8. So that'll be $15.50. So now I can plug that into this equation, 20 minus 15.50, and I got that he had remaining $4.50. All right, so what did we do? We figured out what we started with, what we ended with, and we came up with conversions to do this. Let's actually do a chemistry problem, because that's what we're going to have to do on tests. So let's go back to that one we started with. So a large piece of silver jewelry has a mass of 132.6. We have some other information. What's our goal? Our goal is the density. So we want to get to the density. Well, what do we start with? Well, we start with 132.6 grams. This is a mass. What else do we know? Well, we know that it's we had a graduated cylinder at 48.6. We added in this butterfly piece of jewelry. There's our jewelry, right? And the volume increased it to 61.2 ml. And what else do we know? We know 25 degrees Celsius. That's the temperature of the water. All right, so that's what we have. Let's go ahead and now triage. What type of problem is this? Well, in this problem, it's fairly easy. It says it's density, so we're going to be using all the things we know about density. Well, so let's see. What do we know about density? We know that density is an intensive property. What that means is that it's the same whether you're talking about a small piece of silver or a large piece of silver. The density is the same. And we also know that it's equal to mass over volume. So density equals mass over volume. All right, so density equals mass over volume. Well, I have a mass, but notice I have 2 volumes. And this is where the diagram helps out. Which volume do I use? Well, what is this a volume of? This is a volume of just water. Whereas this 61.2, this is the volume of water plus that jewelry. So what we're looking at is the water plus the jewelry minus the water. That's going to give us our volume. So our volume in this case is 61.2 minus 48.6 milliliters. Plug that into our calculator. 61.2 minus 48.6. That's 12.6 milliliters. So I'm going to plug that in. So 132.6 grams divided by 12.6 milliliters. That gives us 10.5238. All my numbers have that I used have 3, so I'm going to use 10.5, and it's grams per ml. All right, now we go under our check. The check is, hey, it asks for a density. Did I give it a density? Well, I gave it grams per ml. Therefore, I actually answered the question. So I always make sure, hey, did I actually answer that question? Now, there can be a trick. Notice this one just says density. So grams per ml is a unit of density. If you got an answer in grams per liter, that's also density, or kilograms per milliliters, or whatever, right? All you need to do is make sure it's a density. Now, some problems, let's say instead of saying just density, it asks for the density in kilograms per ml. Well, in that case, even though I have a density, I now have to make sure to put it in the right units. So 1,000 grams equals 1 kilogram. So that would be 0.0105 kilograms per ml. So we went through our problem and we made sure that we got our right answer. Now, one thing is, if you look, notice we were given 25 degrees C, but we haven't used it. Uh-oh, does that mean we have to use it now? No. Sometimes problems will give you more information than you need. Okay? In this case, that 25 degrees C didn't matter. One other thing is, notice it gave us that it was silver. Well, in this problem, we don't need to know that it's silver, but sometimes knowing what compound it is can be very important. All right, so here's another problem. Diamond is composed solely of carbon. The Cullinan diamond was the largest natural diamond ever found on January 25th, 1905. It weighed 1,304 carats, where 1 carat equals 200 milligrams. How many carbon atoms were present in the stone? Okay. So in this case, we're given a lot of extra information. But let's go ahead and first, what are we asking for? The number of atoms of carbon. And what are we given? Well, we're given 3,104 carats. Now, it doesn't specifically say what this is, right? But, you know, notice that 1 carat equals 200 milligrams. Milligrams is a unit of mass. Therefore, this 3,104 must be a mass, okay? Sometimes it's not going to tell you, hey, it's a mass or it's a volume, but if you look at the units, that can tell you what kind of measure it is, okay? So we have a mass of 3,104 carats. We're told that 1 carat equals 200 milligrams, and then we're given a date. Dates are never going to be important in this class. And we're given one other piece of information, that it's all carbon. Okay? That's going to become important. Okay? So this is what we have. This is what we want to get. Okay? There's no real diagram here. Nothing's done. We're just figuring out this. But we have what we started with and what we want to get to. All right, so let's triage. What kind of problem is this? Well, there's no reaction occurring. This isn't a density problem. It's not a gas phase problem. But we want to figure out atoms. So this is a type of problem where we're going from a mass to an atoms, right? So we're trying to figure out, hey, how many atoms of that element there are. So what do we know about this? Now, you may not have covered this in class yet, but let's just, you'll get to this eventually. In class, we talk about how you can go from mass to the number of moles, and then to the number of atoms. You can't go directly from mass to atoms. And so here we know that this is based on the molar mass of, in this case, carbon. And the number of atoms, well, that is based on Avogadro's number. Okay, so as soon as I know what type of problem it is, I can start saying, okay, how am I going to do this? Now I think of, hey, I'm going to convert this into a unit of mass I can use, then convert that to moles, and then finally to atoms. All right, so first 3104 carats. Usually we don't use carats. The only time they use it is in talking about diamonds, really. And we have 1 carat equals 200 milligrams. Well, generally speaking, in whenever we deal with molar mass, we want it in grams. So we can convert from milligrams to grams. So 1,000 milligrams equals 1 gram. So when I do this, I get 620.8 grams. Okay. It's a pretty heavy diamond. Anyone would be happy with that. Now that's grams of carbon, right? Because diamonds are just carbon. And now we can go ahead and we can use our molar mass, which we get from the periodic table, to convert to moles, and then from moles, using Avogadro's number, to 6.022 times 10 to the 23 atoms. So when I do this, I get that it was 3.113 times 10 to the 25 atoms of carbon. Very big diamond. And that is one example of how to do a word problem for chemistry. All right, so we did some problems with word problems, some examples. There'll be more in the worksheet. And you know, the real thing is you just got to keep on trying them and trying to figure out. And a key thing in chemistry problems will be that fourth step, the triage. Okay, so always remember, you start with your goal. What am I trying to get to, including units, and what I'm given, including what element or compound it is. We used that one on a diamond, which is composed of carbon. That would have been a totally different problem if instead of carbon, it was nitrogen. So always what we're given, where we're going. Then you can go ahead and draw a diagram. This is really important if it's talking about something you do in a lab or during an experiment. So you might have a beaker and you add some stuff and now it's increased the beaker, the volume, stuff like that. Then you triage. In triage, you try to figure out what type of problem is it. By the end of Gen Chem, you'll have a lot of different problems that you'll have to deal with. And so you have to kind of figure out, okay, hone in on what kind of problem. Once you know that, you can figure out the appropriate equations and conversions, things like molar masses and constants, such as Avogadro's number, or in some cases, you'll have reactions. And so that reaction is another one of those appropriate equations. Finally, you solve it. And always remember, did you answer the question? Always go back and check and make sure you actually answered the question, including getting the right number of sig figs and the right units. All right, bye-bye.